Today we are going to learn about the last and the fourth pillar, which is known as polymorphism. Now, polymorphism is nothing but, I'll just tell you with an example. Now, let's say, no, print 1 plus 2. Now, what will this give us? It will basically give us 3, right? Now, when we run this, we'll get the number 3, right? Perfect. Now, we will print the sum of two strings. Let's say str ing. Now what will this print? It will print the word string. Right. Yes. Now we will do print (1.1) plus 1.2. Now we run, we should get 2.3, and yes. Now what did you observe in this? We added these both. Now, well, I'll just print type of 1. Let's run. And now what is it? It's int. Now this 1 is an object, this 2 is an object. Now inside the class int, they have already mentioned that that if the plus operator is there between two integers, then it is gonna print out the sum. Now similarly in the string class, they'll mention for concatenation. And similarly, let's make this a list 1, 2, 3 plus 4, 5, 6. Now this is merging. Am I right? Yes. Now that is merging. So everything is using the same operator, but as the data type changes, the function of the operator changes. This is known as polymorphism. Okay. Now we are going to learn about operator overriding. It is when you create your own plus sign function and you run it using overriding. Now let's create a class. And now I will tell you one thing. There are real numbers and imaginary numbers. Real and imaginary. Alright. Now, real numbers are these numbers 1, 2, 3, 4, 5. Those. And the imaginary numbers are like 3i plus 4j. Now these are imaginary numbers. We have no value in them in the real world. So for adding them, let's write a simple code. Class. They're complex numbers, right? Complex. And now we'll define init self. And yes, here we'll say self. Okay, wait. We'll say number 1, number 2. Self dot number 1 gives number 1. Self dot number 2 equal number 2. Right. Now the constructor is done. Now we'll define a function named show. Yes. Now we'll write, no, print, we print now we'll say self dot num1 plus self dot num2. We'll say that's num3. Okay, you know what? Let's just write it in a separate function later. Now we'll just print, okay, the value of self dot num num1 comma self dot num2. That's it. Now let's create the object. Let's say see number1 equals complex, and yes, now we'll do number1. Okay, we have to send the parameters. Let's say 1 comma 2. Now here, let's say show is run. As you can see, it says 1 2, but we need like I and J's, right? So what we'll do is okay, I plus comma comma J. Right, now let's print it. Now as you can see, it says 1I plus 2J. Okay, let's create another number. Number 2 equals complex 3 and 4. Number 2 dot ship. Now let's run. And as you can see, 1I plus 2J, 3I plus 4J. Now we have these two complex numbers. Now we'll write a function to add them both. Now I'll tell you real quick how complex numbers are added. Here, we keep the i's and the j's common. Okay. Now this 1 plus 3 would become 2i. No, sorry, 4i. And now this 2 plus 4 gives 6j. Now we should get 2i plus 6j. Now let's write another function. Def add okay. Now I forgot to tell you one thing. Now complex numbers cannot be added using the simple plus sign. It will give you an error. So we need something known as dunder functions, like this one. Okay. Now dunder function is basically when you do underscore underscore and your name and underscore underscore. Everything is the same. You just add two underscores right before and after the function to make it a dunder function. So you can basically now have complete access to the addition, subtraction, multiplication, division, or anything you want to do with complex numbers. So let's do that real quick. Num1 and num2. Now what we'll do is okay, now let's pass only num2 right here. Num2, no, number 2. Okay, right. Now we will say num3 equals, okay, this is just a variable. We say self dot num1 plus number 2 dot, let's say real. Okay, now we say number 2 dot num1. Now number 3 equals self dot, sorry, it's number 4 equals self dot num2 plus number 2 dot num2. Right. Now we will just print num3 and num4. Self dot, sorry, it's number 4 equals self dot num2 plus number 2 dot num2. Right. Now we will just print num3 and num4. Right. Now we will create NO3 equals complex, right? No need, instead of this, we'll just say num5 equals number NO1 dot add. Yes, number1 dot add number2. Now num5 dot show. Okay, let's run. Oh, we got an error. Has no call to add. Okay, for now, let's just remove this as a dunder function, and let's just keep it like that. Now let's run. Why doesn't it have? It does. Show. Okay, you know what? Let's just actually create complex. Now it should work. Okay, now we'll just print number 5. Let's run. As you can see, we got the expected result for I plus 6j. Now this, okay, we can just num5 run. Yeah, this, we got it. Now if we use this dunder function, okay, now instead of writing this dot add and stuff, you can just directly add it. You can just directly add it and print num5. As you can see, we still got the same result. But whereas if you didn't have the dunder method and you write it, it will probably give you an error. Yes, because complex and complex cannot be added with the plus symbol. Now if we make it this dunder, now it will work, as you can see. Now that's it for this video, where we have learned about polymorphism and operator overriding. So meet you in the next chapter. Goodbye.